It can be costly to add necessary security features once a product has been launched or even late in development. On the other hand, leaving security issues unaddressed can have worse consequences. DornerWorks engineers focus on building security into a new device right from the beginning. In this interview, we will be talking to DornerWorks embedded engineer Ray Smith about the importance of security by design and how it can help teams reduce risk while creating better products.
As a developer and as a, just as a person, I love technology. I love the convenience that it can offer me. Oftentimes it's just really cool. But one thing that as a customer of a company's product, one thing I don't want to see is the product that I buy create a vulnerability in my home. If I have devices that open my home up to attackers, or that device isn't well thought out to prevent people from gaining unauthorized access to my home or to my devices, then that's a problem for me. As a developer, my job is to actually make it possible for the devices to be designed from the beginning to have security, to have a product that works well and works well for the customer without creating those types of vulnerabilities. It's something that I think of as a really fun challenge, and it's something that I have a passion for. So I really take it to heart that this is something you want to get right.
How do you build security into a device by design?
Typically, I say you need to start with a robust process. That process may differ on a few minute details, but typically, any process you follow should at least incorporate some common themes, such as understanding the overall context of the data that's being used or passed back and forth or collected. If it's the purpose of the data, who's using the data, uh, who's using the system that's being put in place, what connections need to be made, things like that. Those types of things, and there's more to that list, but things like that need to be understood from an overall view in order to understand what things need to be considered, set in place, locked down, things like that. There's kind of an overall context you need to understand. There's also consideration given for who might try to gain access to the data who shouldn't be allowed to. A process should sort of make a way for addressing that type of thing, identifying who might be attacking the system, who might be trying to steal data, things like that. That process should also take into account the availability of the system, the desired availability, and what might happen if someone does something they're not supposed to. And then that process should take a look at minimizing risk, minimizing the possibility that unauthorized users or unauthorized actors are able to access that system, to minimize that, and maximize the ability to detect all of those things and be able to audit that. There are a few example sets of processes that consider all of those types of things. AWS and Microsoft Azure have frameworks in place for people to put together systems that use their services. There's an open web application security project that takes a look at process for web application developers, things like that. There are other regulatory processes in other parts of the world that try to offer something that can be globally useful. There are definitely lots of examples and resources to look at, but generally, yeah, you want to start with that process.
What are the risks of adding security features to your device later on?
When security is added late or after the fact, you have some deficiencies that aren't necessarily taken into account. You have devices that might not be designed to have critical capabilities that would be needed to implement security. If you're implementing after the fact, then you might miss something that's needed to actually do it well. Those devices might not have a way to reliably and securely update later on, and that's a risk when you don't implement it from the beginning. The device fleets get harder to manage when you have different configurations. And so if you have one configuration that doesn't have security and then one that does, and anything in between, that becomes a lot harder to manage and just to keep an understanding of what the implications are moving from point A to point B. And then there's the risk that the devices themselves may be compromised before you have a chance to upgrade them if you did somehow have a way to upgrade them later. So those are all risks that are easily mitigated by just putting security in from the beginning.